Sisesekule question paper ka May June 2021, physical sciences paper 1. This question paper was written sometime in May June. It was a mid-year examination question paper, so lana so pendula only question 3, and the number links for the other questions akhona kule question papers wathola in the description below. So lana sikhuluma nge-projectile motion. So question yethu ifundeka ngale ndlela ke. A ball of mass 0.06 kilogram is thrown vertically upwards from the balcony of a building 3 meters above the ground. Right, Ulana. This is the balcony of the building, right? Ulana uphosa mhlambe a tennis ball or a cricket ball or something, and then we projector upwards, right? The ball is being projected upwards, and then basipa ne mass yakhona, basipa as well as the height where the ball is thrown, right? And then the ball reaches a maximum height h above the ground as shown in the diagram below, right? The height h is 3 meters plus the height traveled by the ball from its starting position. So let distances will travel a ball from this point all the way up to its maximum height plus the 3 meters nigeza the height h, and then we have to ignore the effects of air resistance. So 3.1 all right, but we reference la which lana basitshela bathi this is the ground. Ngizama analyze the sketches, ngizama keep wonke ama details akhona kule sketch lawo as far as possible. Now with 3.1 question yethu yokuqala bathi name the force acting on the ball while it is in free fall. Angisho in free fall the only force actayo yini gravitational force or its own weight, right? So lana it's question 3. In free fall the only force actayo it's the gravitational force. So 3.1 our answer is gravitational force. It's the gravitational force. 3.2 gravitational force when defining free fall, it's one of the keywords. In free fall the only force actayo must be the gravitational force. Laba we have to ignore the effects of air resistance. So if free fall, in other words, it's in a vacuum. In the real world, now we pose an object upwards. There are two forces acting. It's gravity as well as the air resistance, right? So free fall is a vacuum. Now 3.2. With 3.2, batikiti, the velocity time graph below represents the motion of the ball from the instant it is thrown upwards until it hits the ground. So le graph lana is kombisa the motion of the ball from the point it's released or projected upwards all the way up to its maximum height, and then back to the ground. So le graph lena is kombisa the motion of the ball, like the lifespan ya le ball from la all the way up to the ground. It's being depicted kule graph la below, right? And then babuya ke bathi 3.2 ke write down the acceleration of the ball at time t equal to 1.02 s. If ama graphs wakho ama velocity time graphs wakho for a projectile motion uyawazi kahle, this point represents what? If you pencil, okay, I need to, but anyway, this point la represents the maximum height. Ngoba bheka initially angisho siyabona ukuthi le ball is being projected upwards, so it means izoba ne initial velocity of a non-zero initial velocity. That's why graph iqala, right? And then le ball naliya phezulu. Now le ball naliya phezulu la. The ball loses what? Loses its velocity bit by bit as isikhathi sihamba. So nayifika la at its maximum height, the velocity iba ubani? Iba 0. That's why ngithi at 1,02 the velocity is 0, so it means this is the maximum height. And whether the ball it's at its maximum height or during its motion or coming back from its maximum height, it doesn't matter ukuthi le ball alukuphi, as long as the ball or the projectile is in motion, ne? As long as the projectile is in motion, okusalayo gravitational acceleration I change. You write down the acceleration of the ball. The only force I act yini a gravitational force. So is accelerator due to a gravity. So its acceleration is over equal to its gravitational acceleration. So 3.2, the acceleration of the ball is over a or g equal to 9.8 meters per second squared downward. Why downward? Because a gravitational force is acting downward. The gravitational force is pulling the projectile down. 3.3, but to consider the areas A1 and A2 shown in the graph above. Write down the numerical value represented by the difference in areas A1 and A2. Oh, pencil, Cantula pencil. Okay. Difference. What's the meaning of difference? Asinatela babangazi ke. Minus or subtract. Minus or subtract. We minus or we subtract. So the area under this graph, if it's buyela back to grade 10, we know that the area under a velocity time graph represents what? Displacement. And it represents its displacement. So in this case, area 1 also represents the displacement of the ball or projectile from its starting point all the way up to its maximum height. This is area 1. And the area under this graph, lagu A1, siyabona ukuthi it's the height from lana to its maximum height. And then area 2 represents the displacement of the ball from its maximum height until it hits the ground. So this is area 2. So area 1 and area 2. So now subtract our area 2 no area 1, I get what? 3. I get to 3. So it means area 2 subtract area 1 must give us ubani? 3. The difference between A2. So if value ngizoyithola la, and subtract another value ngizoyithola la, I'm going to get 3 because this subtract this. Logu, this part is cancel this part, or is subtract this part. So now subtract these parts, so sala nobani no 3. So our answer with 3.3 is nigeza 3 meters. 3.4. Now we calculate here. Calculate the 3.4.1, the speed at which the ball is thrown upwards. Okay. Data. Anything also yenza, any calculation also yenza kulo kanje ku projectile motion, even momentum, the impulse. Make sure to keep it data ka, ne? Izokunceda kakhulu. Right, let's choose up as positive, just like Newton's laws. We have to choose in a direction. So let's choose up as positive. So therefore, data is nayo, ne? Remember, ufuna the speed at which the ball is thrown upwards. So tina sizokhetha the instant the ball is thrown and then until its maximum height. Sifuna the initial velocity, or the velocity at which the ball was thrown. Initial velocity. So the data is for when ball reaches maximum height. When ball reaches maximum height, since I choose up as positive and the gravitational acceleration is always acting down, so it means G is about minus 9.8 meters per second squared. And then ngifuna the initial velocity unknown, and then what's my final velocity when the ball reaches maximum height? Final velocity is 0. What else do I have? I know that it takes 1.02 seconds to reach in maximum height according to the graph here. So the ball, when it reaches maximum height, velocity about 0, so it takes 1.02 seconds. Next, I don't have anything else to work with, so this is the lagma formulas way too. Now let's see, ngifuna ubani initial velocity. So initial velocity ngizosebenzisa this formula, ngoba this formula, acceleration or g time, ngifuna initial velocity, I do have a final velocity. So this formula is so apply. So sizothi final is equal to initial velocity plus g, or noma ungafaka h still fine. And then mina ngithanda ukusebenzisa g because young reminder ukuthi I'm working with I'm dealing with the projectile motion and acceleration yami is what is 9.8. now final is 0, initial anginayo, g is minus 9.8, time it's 1.02. now let's calculate together. Minus 9.8 times 1.02, our answer is 0 v initial minus 9.996. Therefore v initial is equal to 9.996 meters per second. So answer I'm rounded off to 3 decimal places. In 2 decimal places is about 10 meters per second. 10 meters per second. So my answers were rounded off to 3 decimal places because the answer am a bit more accurate. So if lo munye round off 2 decimal places, ngiyazi ukuthi answer yami izodlalela duze nale yakhe, right? Okay, so sizosebenza ngale value le ye 3 decimal places. Now sesiyaphi ke manje, sifuna the height h, height h. Before ngizocala ukuphendula le question, I did mention ukuthi i-height yethu is what? It's 3 meters plus the height traveled by the ball from its starting point all the way up to its maximum height. So dinga the height from the starting point to the maximum height. Nangithola ngizoyi-add nalo 3 ngizonginikeza ubani u-h. So 3.4.2, this was 3.4.1. so ngizofuna i-data again, ngiyosebenzisa the data when the ball reaches maximum height. G is equal to minus 9.8 meters per second squared. Why ngifuna the maximum height? Ngisho ngifuna the height from la to la, bese ngizoyi-add analo 3 ngizonginikeza u-h. What else do I have? Initial velocity senginayo is 10, like a 9.996 meters per second. By the way, this is a vector. Remember ukuthi kwamele unikeze le direction. It's 10 meters per second or 9.996 meters per second up. Now still ngisakhetha up as positive. Final velocity 0, time is 1.02 seconds. What am I looking for? I'm looking for delta x. Ngifuna delta x la. So sebenzisa iphi formula? Okay, so sebenzisa this one. In the final velocity, in the initial velocity 2 times a acceleration nginayo I'm looking for delta x, or noma singasebenzisa le, so sinama options amaningi la, or even this one, but I prefer le. So asebenzise this one, it is final squared initial squared plus 2a delta x. So final velocity is 0, initial it's 9,996 squared plus 2 minus 98 delta x. Now let's calculate like about 0, 9,996 squared. Okay, it's 99,92 minus 19,6 delta x. So a simple mathematical manipulation, share transposer, and then it's divided both sides on 19,6 minus 19,6. 99,92 divided 19,6 is equal to, in total it's 5,0 my answer in 3 decimal places. Again, as if I would 3 decimal places, you about 0.98 meters equal to delta x. So therefore h is equal to 5,098 plus 3 is equal to plus 3 is equal to 8,98 meters. This is our answer. So the answer is together. And then since you have here much 3.5 what in now? 3.5 what in again? Okay. After hitting the ground, the ball bounces vertically upwards and reaches a new maximum height in 1,1 seconds. 1,1 seconds. So 3.5, but calculate the work done by the ground on the ball while the ball is in contact with the ground. Okay, and we work energy theory. Actually, a ball with 3.5. This ones are so. This is sugar from its maximum height. You'll point from la. Figure okay, this is sugar from la. Ye will reach maximum height, and then it'll buoy panty. The shy guppy. Ground, and I'll go to size ground. The pin will bounce again. It'll reach a new maximum height after 1,1 seconds. So, is looking at the initial velocity or the velocity just before it hits the ground, and then the velocity after it bounces off the ground. So, the velocity just before and after. Then you insert the work energy theorem. Work net is equal to change in kinetic energy. Change in kinetic energy. So lana ngizodinga information, ngizodinga data la. So ngizodinga the velocity just before it hits the ground. Okay. Let's choose up as positive once more. Up as positive, and then g is equal to minus 9,8 meters per second squared. Meters per second squared. Meters per second squared. Leave the question page. Alright. So if data yam you tata only for this part of the motion. This part of motion. From its maximum height all the way up to the ground. So it means initial velocity it's 0 now. I was saying consider only the part from maximum height to just before it hits the ground. So initial velocity kuzoba ubani u0 meters per second, and then okay, and then yes, not delta x much. Ngoba le ball alisuka from maximum height to just before it hits the ground. So what delta x uyafana no h, so it's 8 calculate 8,098 meters. 98 meters. And then what else do I have again? Mufuna final velocity. Final velocity. This is the velocity just before it hits the ground. So let's inside this formula, Vf equal to initial plus g delta t. No, this one I need 7. So okay, so 7 are this one. V final squared, V initial squared, plus 2g delta x equal to initial, it's 0 squared, 2g, it's minus 9,8, delta x is 8,098 equal to 0 squared plus 2 times minus 9,8 times 8,098. Answer is minus 158,72 meters. But now the square relative over negative. Oh, okay. Because it's polar so the displacement, the delta x is going to be measured as a negative. It's going down. The height is measured downwards. Polar sugar from top to bottom. So it's negative. So negative times a negative is positive. Now, in the answer I'm not having negative. I'm going to square both sides, and then the square root of a negative number, I ends the sense. I still number negative numbers. Syllabus as a high school. So square root both sides. V final it's square root 158,72. So our answer is 12,598 meters per second. Meters per second. If we square up both sides, it's plus minus. So answer it's a negative. Now, V final is going down, but we know what a negative value means. What? Down, according to the way she choose a direction. So it's down. Now I answer it together. So the final velocity. The final velocity just before the ball hits the ground. Just before the ball hits the ground, and then so funa EV initial after the ball has left the ground. So consider the motion from the ground to its maximum height. Again, skip it data food. Skip it data food. Why ngidinga lelo guy lama velocity lawo? Ngoba nanyo calculator ilo guy the work done. Ngizodinga ama velocities because ngine kinetic energy la. And the kinetic formula kinetic energy it half mv squared. So ngidinga initial velocity and final velocity. Right. right. Okay, data G, again keta up is positive 9 minus 9,8 ngoba it's always acting down. And then ngifuna initial velocity la. Final velocity nginayo it's 0 ngoba from ground to maximum height, we know that the final velocity must be 0. I have time here manje, which is 1,1 seconds, because it takes the ball to 1,1 second to reach its maximum height. So therefore ngifuna the initial velocity. Ngizosebenzisa this formula le. Initial ngifuna yona, final nginayo, which is 0 equal to initial unknown plus minus 9,8 delta t 1,1. So therefore minus 9,8 times 1,1 is equal to 10. So 0 is equal to V initial minus 10,78. Therefore V initial is 10,78 meters per second up, right? Up. So saying now my velocity wami here. The work energy theorem apply ngale ndlela le. Apply ngale ndlela le. Nana indlela. Let me use a red pen again. Sing calculator the work net done by the floor or by the ground. EK is equal to half mv squared final minus half mv initial squared equal to ngoba mass constant. I can just take this out as a common factor and then say v final squared minus v initial squared. The mass will remain a constant throughout. So check out, man. According to this sketch nyana ngiproducile la, ngifuna the work net or the W net or the work done. So initially yami nayo la, final velocity yami izoba ngapha ngoba initially just before I hit the ground izoba initial velocity yami according to this formula, and then final velocity yami izoba after I've hit the ground. So this is equal to half 0,06 final velocity. Let's try to calculate how much. 10,78. This is the velocity just after it hits the ground. The takeoff velocity of the ball. Night bouncer. That's the yes, that's the final velocity just before after it hits the ground. Basically a bouncer, that's our final velocity. So it's 10,78 squared minus initial velocity is over 12,598 squared equal to 0,5 times 0,06 10,78 squared minus 12,598 squared equal to minus 1,275 joules equal to 1,275 joules lost by the ball. It's being lost by the ball because ukhumbule bathini, calculate the work done by the ground on the ball while the ball is in contact with the ground. So le ball nale bounce lishayisane nale ground lose energy. That's why uthola i-tennis ball uthi now iphonsa bese bounce. Unokuyibona ibounce so izothi boom boom, the height yenzani iyancipha, boom 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 bese le bola liya stop bounce. It's because every time le bola lakho lithinta i-ground liluza i-energy, right? Liluza i-energy. That's why answer yethu iphuma is a negative la. Okay, question yethu izophelela lana. Yeah, le video beyilong, bengi-expect ukuthi izoba shorter nyana, so but anyway, there was a lot to discuss lana. So thanks for watching. Nangabe uyi-enjoyile, leave a thumbs up. Nangabe une-question, please leave ama-questions wakho in the comment section. In the description below of this video uzothola ama-links for amanye ama-questions contained in this question paper. Ngizobona kule video elandelayo. Nangabe new to this channel, please consider subscribing. So peace. Sharp. Ngizobona next time.